Okay. Next, I want to talk about a third type of test on the general framework of non-hypothesis significance testing in maximum likelihood estimation. So it's called score, or score function. It's called score test. Sometimes it's called LM test, or Lagrange multiply / Gauss score test. So what we're going to do is actually we're going to calculate the vector of first partials or derivatives, what is called gradient of the log likelihood with respect to beta restricted hat. Okay, and that's denoted as G, gradient of beta restrict hat. And the variance of the score function, also called the Fisher information matrix, okay, is equal to, well, basically, expectation of this first partial of log likelihood with respect to the beta restricted hat, multiply the prime that is transpose of the same matrix, and it is equal to what is called information, right? Information matrix, or Fisher's information matrix. And under mild regularity conditions, we don't have to get into a lot of details. This information matrix turns out to be equal to the negative of the expectation of the Hessian matrix of the Hessian of the log likelihood with respect to beta restricted hat. Okay, so under mild regularity conditions. And the score test statistic is equal to this thing. Well, so this is the gradient prime. Okay. So here the score test statistic is equal to the prime that is transpose of the gradient multiplied by the inverse of information matrix, well, which turns out to be the variance of the gradient, right? Then multiplied by the gradient again. It follows a chi-square distribution with the degree of freedom equal to the number of constraints or restrictions, and then we can conduct the chi-square test. Okay. Well, how to implement the score test, or the LM or Gauss score test? Well, based on Qilin Cai, a political methodologist, we're going to follow the following steps. First, we're going to estimate the restricted model only. Okay, looks like in practice, right? Looks like in theory, but in practice, what we're going to do is we're going to follow a series of procedures to get that as a score statistic. First, we're going to estimate the restricted model by imposing the constraints in the unrestricted model and get the coefficients. Okay, so we're going to impose the constraints in the unconstrained model and get the coefficients. So we know the constraints, but we need to get the estimates for other coefficients with constraints. Okay, that is the key point. Then what we're going to do is we're going to feed these coefficients to the unrestricted model. Okay, unrestricted likelihood to evaluate the gradient. So in theta, it's going to be in its initial iteration, or iteration 0. So in theta, we could have that control, right? Then we can get the gradient and the information matrix and construct that, score test statistic. So in terms of implementation, actually the score test is kind of complicated. And so here is a graphical display of all three tests compared in one place. Okay, so this is a Wald test. You see that, right? We'll measure the distance, right? Measure the distance, the horizontal distance, and normalize by the variance of that distance, or the variance actually of that curve, right? That log likelihood curve. So this is LR test, log likelihood ratio test, right? Log likelihood ratio test. So it measures the vertical distance and scale by 2, and we can get a chi-square. And this is the score test, right? Score test basically the first partial of the log likelihood with respect to the parameters with constraints. So it measures basically different locations, different parts of this curve, right? This curve, and measure different things. But here's the thing: the three tests are asymptotically equivalent. So in general, in the majority of the cases, results from these three different, seemingly different tests should lead to the same conclusion. Of the three, so here I'm going to talk about some differences. The Wald test has the worst small sample properties, and it is not invariant to reparameterization. It is not uninvariant. Okay, it is not uninvariant to reparameterization. LR test is probably the most robust test, but it has high computational cost because we have to estimate two models, right? One is constrained and the other one is unconstrained. And the Wald test just involves the unconstrained model. And score test strikes a nice balance, among the three, but its implementation is somewhat more complicated. So there's no optimal test here.